given an infinite series A, where all the terms are positive, and the limit of the ratio of the next term in the series to the current term in the series, as n approaches infinity, is equal to rho, then the ratio test has three rules. So if rho is less than 1, the series converges. If rho is greater than 1, the series diverges. And if rho is equal to 1, then the test is inconclusive. So remember the geometric series, which you can write as follows after expanding a few terms. Then you can see that the ratio test verifies that the ratio of the geometric series is constant. And therefore, if this ratio is less than 1, the series converges, which is consistent with the convergence conditions that we derived for the geometric series. Let's use the ratio test to determine if this series converges. So we take the limit as n goes to infinity of the ratio of the next term in the series to the current term in the series. And doing a bit of algebra, we can write this as follows. And the second term is 1/2, so we can write the limit as follows. And therefore the limit evaluates to 1, so we obtain 1/2. And because this value is less than 1, then the series converges by the ratio test. Let's determine if this series converges by the ratio test. So you may recognize that this is a harmonic p series with p greater than 1, so we know that it's going to converge. But let's see if the ratio test can come to the same conclusion. So we take the limit of the ratio of the next term in the series to the current term in the series. And doing a bit of algebra, we obtain the following limit. So the 3's cancel, and the fastest growing term is n squared in the numerator and denominator. So this evaluates to 1. So because we got rho equals 1, then this test is inconclusive. And the ratio test typically works when you have n in the exponent and factorials. Determine if the following series converges using the ratio test. So we take the limit as n approaches infinity of the ratio of the next term in the series to the current term. And noting that n factorial here is n minus 1 plus 1 factorial. And using a bit of algebra, and 3 to the n plus 1 on 3 to the n is 3. And n minus 1 factorial can be expanded as follows. And similarly, n factorial can be expanded as follows. So we can see that all the terms cancel, except for n. So we can rewrite this limit as follows. And therefore this evaluates to 0. So because we obtain rho equals 0, which is less than 1, then this series converges by the ratio test.